and the second ray which will be passing from the optical center will go straight undeviated. So these are two rays which you have to take for making ray diagrams in case of spherical lenses or spherical surfaces refraction thing, which are called basically lenses, right? So just on the basis of these two rays you can make any ray diagram. Let me make one ray diagram and tell you. Let's take an example for convex and concave both, so that you will get to know how to make ray diagrams. First of all, I'll be making a straight line, that is my principal axis, right? This is my principal axis. Instead of lens, you guys would be making a straight line like this, okay? Don't have to make lens first, make a straight line. Consider this is your lens, whatever, convex or concave. Now make proper markings of focal lengths and 2f. Suppose it is f and 2f are 5 and 10 centimeter. So 5 and 10 here, as well as 5 and 10 on this side. Now suppose my object is here. Take two rays. Number one, the ray which is going parallel to the principal axis, this has to pass through focus. So this ray, make it pass through the focus, right? Second, the ray which is going from the optical center, it will go straight, right? So wherever these two rays are meeting, just this ray actually has to meet a bit more this side. So I'll draw it again. From the optical center, make it go straight, and this is how they are meeting here. So where they are meeting, make the image. This is how you make ray diagram. After that, you can complete your lens, and if you want to, then you can remove the central straight line. But even if you don't, that is actually more preferred by teachers, right? While checking the answer sheets. So this is how you make the ray diagrams. You used only two rays. Number one is the straight one, number two passing through the optical center, which is going to go straight. So depending on these type of conditions, that is where object is placed, you will find the different positions of image. Moreover, I want to make one concave as well, so that I can tell you again the basic difference. As I told you that in case of mirrors, ray number one, suppose this ray which goes straight, it has to pass through the focal length, right? And the second ray which is going from the optical center, it will go straight. So where is the formation of image? On this side. Now what did I tell you about real and virtual images? Real images are always inverted, that means this is a real image, and virtual image is always erect. So this is virtual image. So in cases of mirror and lens, let's further divide them in real image and virtual image. Here also real image and virtual image. Two main points which you should note. Number one, in case of mirror, real image is what? Inverted, and virtual image was erect. Here also same thing, real image is inverted and virtual image is erect. But the second important point, in case of mirror, because real images are those which can be obtained on a screen, because rays are actually meeting at that point. Consider this. Here, for the formation of this image, these two rays are actually meeting at that point. So if I place any kind of screen here, I'll get the formation of image here. But in this case, this ray actually went this way. This is the virtual projection of the ray. That means the ray is just appearing to be coming from that point. It is not actually coming from that point. So this is a virtual image. So if I place a screen here, I won't be finding the image. So in case of lens, virtual image are on the same side of object, whereas real images, they are on the opposite side of the object. But this is not in case of mirror. In case of mirror, real images are on the same side of object, whereas virtual images are on the opposite side of the object, right? These are the two important points of differences. And based on the basic laws of making ray diagrams, now consider these two ray diagrams which I have shown you in projector. First is a convex lens where rays are coming from infinity, that means they are all coming parallel to the principal axis. Second one is a concave lens, again with the same condition. All the rays which are coming parallel to principal axis are supposed to meet at focus, and so in this case which are coming from infinity are supposed to meet at focus, but they will meet virtually at focus. So what happened to these rays? These rays converged to one point, whereas all these rays got diverged. That is why convex lens is called converging lens, this is called diverging lens, right? Next, this is how objects look when you watch it from convex lens. In case of convex, the object, the image is found enlarged, whereas in case of concave, the image is shrink by the size. Moreover, you can relate to this thing that there will be a real image and virtual image thing in case of convex and concave. These are various positions of object which are placed in case of convex lens. That is, first case rays are coming infinity, so they will meet at focus. In second case, rays, the object is placed between f and 2f. So if you draw a ray diagram by that, you will find that the this thing image has moved a bit further between f and 2f. When you will place it at 2f, you will find the image to be at 2f. So all these things you can make first 5 diagrams are those. Infinity at f, between infinity to 2f it will go beyond f and 2f, and it will be size would be diminished. So all of these are real and inverted. 1, 2, 3, 4 and 5, they are real and inverted. Number 3, at 2f, image is at 2f. Number 4, between we have pulled it further 2f and f, the image has moved back from 2f and it will go beyond 2f to infinity. And lastly, from it is placed at focus, so at focus it will form at infinity. It is exactly same what we have done in case of concave mirror, right? The only difference is, what is the difference? Difference is in the position of object, because these are real and inverted, that was also real and inverted. They were on the same side, this is on the opposite side, that is the only difference. Lastly, if I further place it inside the focal length, this is my lens f and 2f, object is here, this lens, this ray has to pass through focus and this ray optical center. So these two rays are not going to meet in this side, so I have to extend both of them on the back side. Wherever they will meet, that will be the formation of my virtual image, virtual and erect and on the same side, right? This is how you draw ray diagrams and you write positions for that. So before we start learning the formula for lens, that is lens formula, what was the mirror formula? 1 upon v plus 1 upon u is equal to 1 upon f. And what was the magnification? Magnification was, in cases of lens, minus v upon u, right? These are in case of mirrors, sorry, this was in case of mirrors, right? In case of lens, the difference in the formula is this becomes negative and this becomes positive. This is lens formula and this is the magnification formula. We are going to do the this numericals on this basis. Also, I will tell you how to derive this relation, though this relation derivation is not in your syllabus, but I will still tell you just in case you would like to, or sometimes if teacher asks out of curiosity how does this formula come, I will tell you for that. So before going to that part, let's know about some more type of lenses, which are, first one, this is a convex lens, or this is actually called double convex. This is concave or double concave. This one is, first side is plane, second side is convex, so plano-convex. This is plane and concave, plano-concave. This is convex and that is concave, so this becomes convexo-concave. And here concave and convex becomes concavo-convex. So as they are in shape, hence there is the name. Simple. So let's move on to the formula of lens.